In this video, we'll be discussing how to restrict the rows returned by a query using the where clause. In the previous video, I covered data types. Now we'll be talking about the where clause. We've already discussed the select, from, and order by clauses, and today we'll be covering the where clause. Where comes after the from clause and before the order by clause. The where clause is optional, as is the order by clause. In the where clause, SQL evaluates the conditions and returns records where they are all true. For a simple condition comparison, we need a column name, something to compare against, some type of comparison, and then something to compare to. This is easier to show than it is to explain. So I'm going to switch over to SQL Server, and we're going to do some demo. First thing I'm going to show you is comments. I'll be using comments throughout all of the demo, and I will post the file when I'm done. So in SQL Server, -- this is a single line comment. And then we have /* and */. So it's either a multi or a partial line comment. It will comment out anything between the two ends of the comment. So all of the demo files will have comments as well as examples that will continue to build. If I go ahead and modify a query, I'll take a copy of it so you have the original and then paste it below and discuss what was changed. So we're on our Northwind Traders database. If you'll remember, they are a company that sells specialty food items to their customers. I'm going to go ahead and open this database and I'm going to look at the tables. So we've got categories, customers, employees, employee territories, order details, orders, products, regions, shippers, suppliers, and territories. We're going to start by looking at the employees table. So I'm going to open this up and look at the columns in this table. And SQL Server lists them all for us, including their data types and if they allow nulls or not. So in this table, employee ID, last name, first name, hire date, and email address are required fields. They may not be null. Everything else could have a null value. So let's keep it simple. Let's start by looking at employees who live in the UK. I'm going to start with star. This is not a great practice. You should not do this in production. But for simplicity's sake at the moment, I'm going to use star. Select star from employees. I'm going to use E as my table alias. This just makes it a shortcut when I want to find my columns in IntelliSense. So if I run this, this will show me all the employees, regardless of where they live, not necessarily just in the UK. If I want employees in the UK, I need to add a where clause. And I would say the column first, so my column is country, or e.country. And as I start to type, if I do e dot, it shows me a drop-down, the IntelliSense, of all of the country, or all the columns in the table that start with C. So now I can just hit country, where e.country equals UK. Remember, in SQL Server, character strings go into single quotes. You cannot use double quotes here. So if I go ahead and run this, it will show me the results and it will show me the 4 employees that live in the UK. And in the bottom right-hand corner here, I can see it says 4 rows returned. Now, if I want the opposite, if I want to see everybody who doesn't work or doesn't live in the UK, employees not in the UK, I'm going to go ahead and copy this query. And I'm going to say where country is not equal to UK. So I can use exclamation point equal sign for not equals. And that shows me 18 rows, everybody except the UK people, if I give a scroll through. I can also do this a different way. I'm going to make this a little bigger. Instead of exclamation point equal sign, I can do the less than and greater than together to make a not equals. And when I run this, that also gives me 18 rows. So if you are a programmer, you are typically going to default to the exclamation point equal sign, and that is perfectly fine. And if you are somebody who has not been a programmer, you typically tend to default to the less than greater than, and that's fine too. You'll find that there are a lot of things in SQL that can be done multiple ways. As long as it works and it runs efficiently, it's a correct way to do it. I am not picky about how you do these things. So those are two ways to find employees who don't work in the UK. Let's move on and look at a different field and do a different comparison. So let's find employees hired on or after January 1st of 2010. Select star from employees E, where E.hiredate. So on or after would be greater than or equal to 1/1/2010. And I'm going to go ahead and run that. And it shows me that there are 10 employees hired on or after this date. I could have done this another way. I could say employees, select star from employees, where E.hiredate is strictly greater than 12/31/2009. And one of them this, it would mean the same 10 rows. Those are our simple comparison operators. Our equal or not equal, our greater than, less than, greater than or equal to, less than or equal to. We're going to do a couple more examples with this, but get a little bit more complicated as we go. So for a minute, we're going to switch over to our products table. And when I say switch over, I mean more of a switching gears type of thing. So I'm going to open up the products table so we can look at the columns. And we're just going to start by doing a select star from products. And this is going to show me all of my products. It's nice to be able to just look at your data from time to time and see what information is contained in the table. So let's do a query for products that are sold for more than $30. If we look at this table, we can see we've got a unit price field and a wholesale price field. So the unit price is what the company sells their products for. The wholesale price in this database is what they purchase them for from their suppliers. If I want to see products that are sold for more than $30, I'm going to start to limit my select list here. But to make life easier, I'm going to start with select star from products, P, give it an alias. Now I'm going to come back up to my select list. Once I have my table listed, IntelliSense will pick up my columns, and then I can select the ones I want. Select P.product ID, P.product name, P.unit price. So that will show me in the end, when I run this, that I have only products that are more than $30. So I'm going to add my where clause after my from clause, where P.unit price is greater than 30. Remember, numbers don't get single quotes around them. And if I scroll through my results, I can quickly see that there's nothing that is less than $30. Now let's do the same query, except let's include the profit margin as well. This is the difference between what a company buys the product at and what it sells it at, which is the calculation. So I'm going to include it in my select list, P.unit price, so what they sell it at, minus P.wholesale price, what they bought it for. I'm going to go ahead and run this. And I have my product ID, my product name, my unit price, and a no column name column in my results. The reason it says no column name is because I defined a calculation, but I didn't give it an alias. So if we want to fix that, I'm going to put it in my comments and an alias for the column. The column alias allows us to rename a column. So I can rename any of these columns here. And just to illustrate the different ways I can do that, I'm going to do a couple of them. If we want to have a space in our column alias, we have to do it either in single quotes, double quotes, or square brackets. So I'm going to show all three ways to do that here. I'm going to use the as keyword just to show you. As is optional when defining an alias. So as product ID, so that's one way to create an alias with a space in it. I'm going to skip the as here because, again, it's not necessary. I'm going to call this one product name. So this is the only place in SQL Server we can use double quotes, is in these column aliases. And then unit price, I'm going to use square brackets. And then for my profit margin, just for fun, I'm not going to use any of those things, and I'm not going to put a space in it. But I am going to use an as, because otherwise it might be a little bit confusing. If I don't have that as, it's just unit price minus wholesale price, profit margin. It looks confusing, which is why we often use the as there. It would still work without it. So now when I run this, product ID has a space, product name has a space, unit price has a space, profit margin doesn't because I told it not to. So these are the 4 ways we can create column aliases. Single quotes, double quotes, square brackets, or nothing surrounding the alias name. If I try to make this profit margin one have a space, I would get angry red squiggles. And SQL Server would give me an error message that says incorrect syntax near margin. This is because when you have a space in an alias, you must use the single quotes, the double quotes, or the square brackets. Okay, so let's modify this query just a little bit. Display products with the profit margin of greater than $10.50. So I'm going to copy the majority of my query. I'm going to skip the where clause from before. And I'm going to say where profit margin greater than 1050. You'll notice right away I got some red squiggles under profit margin, and it tells me invalid column name profit margin. That's because I cannot use my column aliases from my select clause in my where clause. SQL Server doesn't allow this. And if I am just being a little headstrong here and I want to try to make it run anyways, it's going to give me the same error message when I run it. So if we want to compare to a calculation that we created in our select clause, we actually have to copy that calculation. Where p.unit price minus p.wholesale price is greater than 1050. That does work. However, interestingly enough, I can sort it by my select clause alias. Even though I couldn't use it in the where clause, I can use it in my order by. That has to do with the order of how SQL Server processes queries. It doesn't process it from start to finish the way we write it. So the long and short of it is you may or may not be able to use your select clause aliases in other clauses. Now we're going to go back to our employees table and do a couple more queries. Let's say we want to know employees whose last names start alphabetically before K. Interestingly enough, our less than, greater than operators will also work with character strings. I'm going to select from employees E dot first name, E dot last name, where E dot last name is less than K. So all the values less than K. And when I run this, you can even sort this. And I can see that I got everybody who's returned has a last name that is less than K. So these comparison operators don't just work with strings and numbers. We can also use them with dates. We displayed that already. We have some additional comparison operators as well. We have the between and not between operators. They're used for ranges. In and not in, that look for a specific set of values. And like and not like, which are wildcard search. So between and not between finds values in a specific range. So if I want to find employees whose last names are K through R. Maybe I'm creating alphabetical lists for an employee sign-in sheet. So last names that start with K through last names that start with R. I could use my between operator here. So I'm going to copy this query, paste it below. So where E.last name between, let's do K and R. Okay, I get 4 employees. That doesn't really tell me, though, if I got the people I should have. I don't have anybody after R, but I also don't have any R's included at the moment. So I'm going to comment out my where clause, and I'm going to run the query again. And when I look down, I see that I have 2 employees with R last names that were not included. So this doesn't quite work. This doesn't include employees with R last names. The ranges are inclusive, so if someone had the last name that was exactly R, just the letter R, they would have been included. However, that's not very likely for someone's last name to be a single letter. So to get our whole R range, we actually have to change this to an S. And now when I run this, I do see the 2 employees with R last names. Now if I want to get everybody except the employees whose last names are K through R, I can do that as well. Whose last names are not K through R, I can say in my where clause, where E.last name not between K and S. And now I get everybody up through J, and then S to the end, which is apparently just S's. So those are our between and not between operators. Then we have the in and not in operators. They return records that match or don't match values in the specific list. We have to give the list in parentheses, and the values have to be separated by commas. So if I want to see employees in the US, I'm just going to start with a star from employees. If I look at the countries, I see I have USA and US. Both of those need to be included. So this is an example of some bad data entry, but that happens quite frequently in real databases, so we need to be aware of those things and handle them as well. For this, I'm going to use my in operator. I'm going to go ahead and give my employees table an alias, where E dot country in, I put my parentheses and I list my values inside of them. So US, USA. Gives me my 18 employees. And if I want the ones who are not in the US, I use the not in operator. And that returns me my 4 UK employees. Next we have our like and not like operators. These perform a pattern or wildcard search. They're used with the wildcard characters. So there's an underscore that represents exactly one character at whatever position it's placed in the string. There's a % sign which represents any number of characters, including 0. And there's the option to include a list of characters or exclude a list of characters at a certain position. And this will return rows that do or don't match the condition. So do if you use the like operator, and don't if you use the not like operator. So let's go ahead and look for last names that start with S. I'm going to go ahead and grab that query from up here. Select E dot first name, E dot last name for my employees E. Where last name, I could say between S and T. And this works. Just my S employees. Or I could use my wildcard search for it. Where last name, like. Now I have to create my search string. So I want the last name to start with an S, so the first character of this search string that it's going to match against starts with an S. After that S, I don't care what characters we have in the string, whatever are in somebody's last name. So I'm going to put the percent sign to indicate that there can be any number of characters after that S, as long as the string starts with S, returning the last name. And when I run this, I get the same list of characters. So let's make it a little bit more complicated now. Let's look for employees whose last names end with SON. I'm going to copy paste so we can keep using that. Where last name like, in this case, at the beginning of my search string, I have no idea what the first couple characters are going to be. So I'm going to enter the percent sign. All I know is that it must end in SON. And there can be no characters after the SON. So my search string is percent %SON. This is what it's going to match against. And when I look at my results, I have Jameson, Johnson, and Stevenson. Now, what if I know that somebody's last name was that sun sound, not necessarily S-O-N, but something that sounds like sun, sense, and something like that. I'm going to do that one next. Employees whose last names end with the sun sound. So instead of saying we're E dot last name like %SON, I'm going to use an underscore here. Say there must be something there. Some number of characters in the last name, an S, some character, and an N. And that gives me Jameson, Johnson, Stevenson, and Stevenson. Okay, that's good. But what if I had something that didn't have that sun sound in there? What if they had a strange last name that ended in SHN? That would have been included here. So I can limit what characters I want to be returned there as well. We want to ensure that it's not a non-vowel. And I want certain ones. So I'm going to say the E. It could be an E. It could be an I. It could be an O or a U. So I put those into square brackets. And it says to my search string, it has any number of characters at the beginning. There's an S. After that S is either an E, I, O, or U. And then after that is an N. and that returns me the same 4 employees. So that's our wildcard search. So this is all well and good, but what if we want multiple conditions together? We can do that too. We can use logical operators to combine conditions. So we have the not operator, which reverses the meaning. We have the and operator, forces both conditions to be true. And we have the or operator, forces at least one condition to be true. The order that these are evaluated is not, then and, then or. And in order to do this, if we're not really sure or we want to override the default order, we're going to use parentheses, kind of like order of operations in math class. So in math, exponents always come first, then your multiplication, division, left to right, then your addition, subtraction. And if you need to change the order, you use parentheses. Same thing here. So let's go ahead and do a couple of these. We're going to move to our customers table now. So let's go ahead and look at the data first. I'm just going to write a select star from customers and run that. And here's all my customers. I can go scroll through. There's 92 of them. So let's say we want to look at companies that start with B. Companies whose names start with B. Select from customer C. I'm going to go back to my select clause and select some columns. C.company name, C.city, C.country. Now I'm going to go ahead and do my where clause. Where C.company name, like B% starts with. And we can see that we have 7 companies that start with a B for their name. Now, what if I want to look up a particular company? Let's say I want to look at B's Beverages. I just want to display all the information for B's Beverages. Where C.company name equals, now if I look at this, there's an apostrophe there. Oh, sorry, from customers, not companies. B's Beverages. But you'll see when I put in that apostrophe that's supposed to be in the word, it got a little angry and confused at me. It's not really sure what's going on here. So because the apostrophe is our special character for surrounding our text strings, when it's inside of our text, we actually have to escape it. And in order to do that, we simply add another apostrophe. So the 2 apostrophes in these beverages, there will become 1 when it runs, and it will show me these beverages. So we need an extra single quote. So let's go ahead and do a combo condition here. Let's look at companies in Spain and France. select star from customer C, where that company or that country equals Spain, and C dot country equals France. I'm going to run this. And I get no data. But if I look at my data for all of my customers, I can see that I've got customers in Spain and France. So something went wrong with our query. What happens is that SQL evaluates this where clause for each row. So this says for one row, the country has to be Spain, and at exactly the same time for that same row, the country has to be France. So this will never work. What we have to use here is an OR condition. If I use this OR condition, I'll see that I get 16 companies that are both Spain and France. Okay. So let's make this a little bit more complicated. Companies in Spain and France whose names start with B. Where country equals Spain or country equals France, and see that company name like B%. Okay, good, I got 7 rows. But when I look at my data, I've got a bunch of rows that don't start with B. One thing about SQL, that's a little bit different than about programming, is in programming it's really not that easy to write syntax that is wrong but gives you an answer. In SQL, it's really easy to write a query that doesn't give you an error but still isn't correct. It's really important to check your data, to check your results. So what happened here? I've got my 3 companies that start with B, and they're in France and Spain. And then I've got all these companies down here who don't start with B, but they're in Spain. So what happened? What happened is our order of operations. Ands happen before ors. So what happened here is that SQL said, okay, the country name equals Spain, check, 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 check. Or country name equals France and the company name starts with B, check and check. So what we really want requires parentheses if we're going to go this route. So the parentheses go around the pieces that you want to run together. My parentheses go around the countries. So the country is Spain or the country is France. One of those has to be true. And the company name has to start with B. Now when I run it, I get the expected 3 results. So that works. If I really don't like my parentheses, I could force it to work a different way. I could force the rules to work. So I could say where C.country equals Spain and the company name starts with B, so these 2 things have to be true. Or the country is France and the company name starts with B. Or these 2 things are true. This does work, but is really ugly. Don't do it. Don't do it this way. But we'll give you the right results. What should we do? The best way to do this going to copy this one real quick. So this is the best way to do this. I have two values for the same column. I shouldn't really use an or statement here. I should use an in statement. For country in Spain, France, and CDEC company name like B%. Same thing, much cleaner and easier to understand. That's our logical operators. So when working with these, this is a truth table, if you've never seen one of those. So with an AND operation, the only way that the data will be returned is if both conditions are true. With an OR operation, the only way that data won't be returned is if it's a null result or if both conditions are false. So when you've got multiple types of operators, the order that things get resolved is first the math gets done. So if there's any math operations, those happen first. Then we do the less than, greater than, less than or equal to, greater than or equal to, like, not like, between, not between, in, not in, all those type of operations. And then we do our logical operations last. So then the not, the and then the or. So let's talk about nulls now. Nulls are the absence of data. Null means that it does not exist. Something can be null or it cannot be null. Null never equals anything because it's an unknown. You can kind of think of it like infinity. Nothing can ever equal infinity because you don't know what that is. Nothing can ever equal null because you don't know what that is. It's not a known value. So to look for nulls, we have to use is null or is not null when we compare for the column. So let's go ahead and look up that. We're going to go back to our employees table. Let's look for employees who are active. So let's just start with a select star from employees. And let's figure out how we know this. If we look through this table, and we go through columns on the left-hand side as well, we won't find any column that's called active. The only thing that gets us close is the termination date column. So an active employee means they haven't been terminated. Terminated just means they don't work there anymore. It doesn't necessarily mean they were fired. So if I look at termination date, here's one employee with a termination date. Here's another one, and here's another one. So there are 3 not active employees, or inactive employees, 22 total, which means we have 19 active employees. So to find only the active ones, we say where termination date is null. And that gives us the 19, where there's no value in the termination date. Now, if I want to see inactive employees, I say where termination date is not null. And that will show me only those 3 that have a value. Now, a common error here is to try to use equals or not equals for null. So if I say where termination date equals null, unfortunately, I don't get a syntax error here. That would be very helpful. I just get no data. Remember, null is unknown. The termination date is never unknown, but it could be null. So you can't use equals or not equals with null. two more topics here. These are ways to restrict rows that don't involve the where clause. So sometimes when we want to see data, we just want to see a subset of rows in the table. We don't need to see all 100 or 1,000 rows in the table. We just want to see some. We just want to look at what the data is. We can do this using top N. This gets used in our select statement. If I want to go to my orders table, select star from orders, O. And if I'm just looking at data, I probably don't need to look at all 831 records. Looking at about 10 might be good. So we're going to display 10 orders, any 10. Don't really care. So right after select, I can say top. And this was where the N would go, and N represents any number. So if I want to see 10, I say 10. Then I list the columns. If I don't really care to take them all out, I could do star, or I could say O.OrderID, O.OrderDate, O.ShipDate. And that's going to give me 10 orders. Now, if I do want them sorted, or I want 10, but I want a particular 10, I can also use my order by clause. Display the 10 most recent orders. So for the most recent, I say order by order date, descending. Descending says newest to oldest. So it's going to sort my data and pull the most recent orders. And there they are. So top always goes in the select statement, and it always goes right after the select keyword. Then if we want to show unique values, we can use our distinct keyword. This also goes in the select clause. Distinct applies to all of the columns that are listed. It returns the unique combination of columns. So let's display the unique countries the customers are in. Select from customers, C. I'm going to go back and edit my select clause, C dot, I'm just going to make country. So if I just simply say select C dot country from customers, I'm going to get duplicate values because I didn't tell it to give me unique ones. I want unique, I include the distinct keyword, and this also goes right after select. So distinct C.country gives me a unique list of countries for this table. There are 21 unique countries. Remember, there were 92 customers. Now, if I wanted to display the unique cities and countries, I can do that as well. In order to do country and city, I simply add the city to my select clause. Now I have 70 unique combinations. So distinct applies to all of the columns in the select clause. And you could use this with a where clause, you could use this with an order by clause. Distinct and top N can be used with multiple different clauses as well. That concludes our video on the where clause for today. I will be posting this demo file to Blackboard, so please review it if you have questions.